Today, we are diving into a really fascinating research paper. It's called CEPEDALoCo, and it's all about a new event-driven architecture designed to bring together complex event processing and blockchain, all using the power of low-code. Let's get right into it.
First off, let's give credit where it's due. This research comes to us from Jesus Rosa Bilbao, Juan Bubeta Puig, and Adrian Rudel, and it was published in the Internet of Things Journal back in 2023. So you know we're dealing with some seriously cutting-edge stuff here.
All right, so here's our game plan for this explainer. First, we're going to talk about the big problem, the IoT data challenge. Then, we'll look at three powerful but separate tools that could be part of a solution. That leads us right to the main event, CEPEDALoCo. We'll break down a cool case study on air quality, check out the results, and wrap up with why the future is probably going to be low-code.
Okay, first things first, the IoT data challenge. How on earth do we start to make any sense of all the digital chaos that's happening around us all the time?
To really get a grip on how big this challenge is, just look at this number, 21.5 billion. Let that sink in. That's how many connected IoT devices we're expecting by 2025. This isn't just a trickle of data anymore, it's a full-blown, non-stop tidal wave of information.
So what kind of problems does this data tsunami actually cause? Well, for starters, you've got data heterogeneity. Basically, your smart toaster, your car, and a factory sensor, they all speak completely different digital languages. Then there's real-time analysis. You have to somehow sift through all that noise instantly to find the important stuff, what the paper calls situations of interest. And last but not least, secure storage. Once you find something important, how do you save it so that it's decentralized, totally tamper-proof, and you can trace it back?
So we've got the problem nailed down. Now let's look at the tools we could use to build a solution. We're talking about three really powerful but, traditionally separate and complicated technologies. Our first tool is Complex Event Processing, or CEP. The best way to think about it is like a super smart smoke detector, but for data. A regular smoke detector just looks for one thing, smoke. But a CEP system is watching tons of different data streams at once, looking for a very specific combination of things to happen that signals something important is going on.
Tool number 2 is something you've probably heard of, blockchain. Now, its role here is super specific and really important. It's our unerasable, totally trustworthy record keeper. So after that CEP engine spots a situation of interest, the blockchain is where that event gets carved into stone, digitally speaking. It's the ultimate source of truth for the whole system.
And our final tool is the real secret sauce, the thing that makes the other two accessible, low-code. See, instead of needing an expert programmer to write a mountain of code, low-code platforms let you build powerful apps using visual, drag-and-drop interfaces. Seriously, think of it like building with digital Lego blocks. It just opens up these incredibly advanced tools to way more people.
So we have these three amazing, powerful technologies. But getting them to work together, that's always been the really hard part. And that brings us to the hero of this paper, CEPEDALo, the integration engine that finally gets them all to play nice.
And the architecture is actually pretty simple to understand. You can think of it in three logical layers. Step 1 is the data production layer. That's all your IoT gadgets and sensors out there, just pumping out raw data. Step 2 is the data processing layer. This is the brain of the whole operation, where the CEP engine is doing its thing, hunting for those complex events. And finally, you've got the data consumption layer, where those important events get locked onto the blockchain and shot out to dashboards or alerts.
Now, this all sounds fantastic in theory, right? But the real question is, does it actually work out in the wild? Well, let's get to the case study, where the researchers put this whole system to the test monitoring air quality in Spain.
So the researchers put together a really solid test. They set up 12 different IoT sensors at 3 weather stations in Spain, measuring everything from CO2 to humidity to pollutants. Every 10 minutes, all that data was piped straight into the CEPEDALoCo system. And the goal was pretty straightforward. Could the system automatically spot complex events, like a sudden drop in air quality or even just a sensor going haywire?
And this right here, this is where you can see the magic of low-code in action. This is the actual editor they used. Instead of coding, a developer can literally drag and drop components to build a rule. You can say, hey, if the CO2 level goes above this number and the temperature drops below this number, then trigger an event. It's visual, it's intuitive, and it's incredibly powerful.
This quote from the paper really just nails the core idea. The key word here is automatically.
The system is always watching, and the second the conditions are met, bam, a complex event is created by the CEP engine. No human has to lift a finger.
And here you can see the whole chain reaction. The system flags a moderate AQI event. Instantly, two things happen. One, that event gets logged as a transaction on the blockchain forever. Two, an alert just like this one gets sent out through Telegram. We're talking from detection to notification in seconds. So, the moment of truth. Did the system actually deliver? Let's dig into the results and what this could mean for the real world.
Get this. In just a 15-day test, the system found, processed, and securely logged 11,229 complex events on the Polygon blockchain. That's not a typo. This proves the architecture can absolutely handle a high-volume, real-world data flow.
And all that valuable data isn't just stuck on a hard drive somewhere. It's made useful right away. This is the dashboard from the experiment. You can see at a glance how often different events popped up. For instance, it looks like there were a bunch of cold, high-risk temperature events. This is intelligence you can actually act on, delivered instantly.
Okay, now this next part might just blow your mind, especially when you think about using this for real. The cost. You'd think storing over 11,000 transactions on a blockchain would be expensive, right? Nope. The average cost to permanently store each one of those events was less than 1/10 of 1 cent. That is just incredible. It makes the whole thing economically viable.
But what about the people who have to actually use it? Did the low-code part really make life easier for developers? You bet it did. 100% of the developers who tried it said it was useful and that it cut down on development time. On top of that, it met the expectations of almost 87% of them. That's a huge thumbs up for the low-code approach.
So let's zoom out for a second and think about what this all really means. This kind of innovation points to a future where powerful technology becomes way more accessible, way more integrated, and it's all built on these low-code ideas.
CEPEDALoCo managed to brilliantly weave together IoT, real-time analytics, and blockchain, making them work together seamlessly. So, I'll leave you with this to chew on. What's next? What other super complex, powerful technologies are just sitting out there, waiting for a clever, low-code solution like this to unlock them for the rest of us?
And that's our breakdown of CEPEDALoCo. All the amazing work we talked about today is detailed in the paper you see here. Thanks so much for tuning in.